Okay, let's go through a little quick example. We have 5 processes here, process 0 all the way to 4, and we have 3 separate independent resources, A, B, and C. We have 2 questions. The first one is asking us to compute the need matrix, and the second one is to actually look at whether this is a safe state or not, and then to give the sequence. So in order to do this, the first one we need to do is compute the matrix, the need matrix. And in order to do that, the math that we need is need equals max minus allocation. And I'm going to use technology here and update this. Cool. So basically, I'm comparing all of this together in order to get my need matrix. And I'll just do a very quick example for the first process. So the first process is I'm looking at process 0, and it's 7 minus 0, which would equal 7. 5 minus, so 5 minus 1, and then 3 minus 0. This gives me 4 and 3. So my need is going to be 7, 4, 3. Okay, and then going down the rest for process 1, it's going to be 1, 2, 2. For process 2, it's going to be 6, 0, 0. Process 3 is going to be 0, 1, 1. Process 4 is 4, 3, 1. So this is our need. Cool. So need matrix just tells us what is remaining in order for our system and for each process in order to complete its task. Now, let's go through the next step, is checking whether if a system is safe or not, and this is where we would run our algorithm. So in order to do that, sorry, they're doing cleaning in the background. Okay, let's initialize our work. So step 1, we're going to initialize work. And this is going to be coming from the allocation, from our available matrices. That's going to be 3, 3, 2. And then our finish sequence is all going to be set to false. Okay, so we're starting out with this. And in order to find the process where the need is less than but equal to work, we're going to go through the sequence. So you need to go through all the processes to find a true statement for this. So going through this, we'll have process 0, process 1, process 2, 3, and 4. So going through all of them, we have 7, 4, 3, 1, 2, 2. These are all of our needs. And we're checking against our work from the very beginning. This is going to give us a starting place. Going through this, we definitely can't use our first process, but we could definitely use our second. Can't use the second process, but we can use the third one, and then we can't use the fourth one. So knowing that, we're going to start with the first process. And this is basically, now we're going to go through. So we have our work, which is equal to 3, 3, 2, and then we have our unfinished sequence, which basically goes from 0, 1, 2, 3, 4. And we're going to update these two while running this hypothesis scenario. Through the first iteration, let's look at process 1. Again, we have this example. This tells us that yes, this works. So I'm going to have this running sequence. and I'm going to add the first process because it was successful. Now, once I was able to pass the first process, we're going to update our work. Again, our work is 332, and in order for me to update that, it's going to be work equals work plus allocation. Again, this is coming from our algorithm. So the allocated resource for the first process is 200. So I'm going to cut that out so that I don't mix it up. And what we're left with is 532. So this is from process 1. So let's check process 2. Now, we don't have to do that. What we can do is move this and update it with the new work, which is 532. Again, we don't pass this, so we're going to skip over process 2 and go straight to process 3. Process 3, it's definitely doable because we have 5, much bigger. So if you look at it, this is doable. Now let's get the allocation for the process 3. And the allocation for process 3 is 211. So what we're left with is 743. So this is our updated work. Now if we compare it to process 4's need, we're definitely able to pass it. So just doing a sanity check, correct, works perfectly fine. Let's look at what's allocated for process 4. It's going to be 002. Let's add that. So now we're completely updated. We have 745 is our new updated process. Well, let's go loop back to process 0. It's 743 is that less than or equal to 745. We definitely can pass this. Let's deallocate. Yep. 010 from process 0755. Let's go to process 2. Process 2 says it needs 600 or 600. That's definitely less than 755. And then we'll deallocate that, which is 302. 302. Then we have a final number of deallocated resources of 10, 5, 7. And if we look at our sequence is going to be process 1, process 3, process 4, process 0, process 2. This is our safe sequence. And that's how you answer this question. So you got your need and you got your sequence. So all of these return to true by the end. Okay, hope this helps.